Hello, grade 7s. Welcome to this week's assignment and lesson 5.5, Conduct Probability Experiments. You can find this on page 183 of your textbook. So the goal of this lesson is to conduct probability experiments and organize results, and compare experimental probability and theoretical probability. So there's a couple things that you need to know for this lesson, and basically you need to know that theoretical probability is the expected outcome of an event occurring. So this is what we've been looking at so far in this unit. We've been only talking about theoretical probability, what we think is going to happen. The difference is that experimental probability is an event occurring based on the actual experimental results. So you may ask, what is the difference? And for instance, you could take a quarter. How many times would you expect it to land on heads? You might say 50% of the time. This is the theoretical probability. This is what we expect to happen. Okay? Now take that same quarter and toss it 20 times as I did. As you can see, the outcomes below are a bit different than 50% of the time. So I flipped heads 7 times and tails 13 times for a total of 20 times. As you can see, the experimental probability wasn't quite exactly what we expected to happen, as I flipped tails 13 out of 20 times, or 65% of the time. All right, we'll go on to the example. You can find this in page 184 of the text. I would encourage you to pause the video here so you can bring up the example. Again, it is on page 184 of your textbook. All right, example number 1. At summer camp, the counselors have created an obstacle course. Each camper must travel through the obstacle course one at a time. Halfway through the course is a fork in the path. Campers must choose to go either left or right. Halfway along each fork is another fork. Campers must again choose to go either left or right. Andrew flips a coin twice to model the possible choices of any camper. A head indicates left and a tail indicates right. The following chart shows the results for 100 pairs of coin flips. All right, so as you can see here, I have made the chart here. It's the same in the textbook. The only thing that I added is the total at the bottom. So if the camper flipped heads and then heads, they would make 2 left turns. That happened 22 times. If the camper flipped a heads then a tail, they would make a left then a right. That happened 24 times. If the camper flipped a tails then a heads, they would make a right then a left. That happened 27 times. If a camper flipped a tail and another tail, they would make 2 rights. That happened 27 times. If you added up these experimental results, you would get the total, which is 100. All right. So question A, from the data, what is the experimental probability of taking 2 left turns? Okay, so up here we can see that here's the 2 lefts, okay? That comes from flipping 2 heads. That happened 22 times out of 100, okay? Highlighting those there so you can see them. So we have to remember our formula. Probability is equal to favorable outcomes over total outcomes. So right now our favorable outcome is 2 left turns. So we know that happened 22 times out of 100. If you divided the top number by the bottom number, you would get the decimal number, which is 0.22. If you multiplied that by 100, you would get 22%. Question B, what is the theoretical probability of taking 2 left turns? All right, so here's the theoretical probability. They have made a chart on page 184, or sorry, a tree diagram on page 184 I have made a chart because that's easier for me to make in a Word document. But the camper could flip ahead, then a head, and the outcome would be head, head. They could flip a head, then a tail, and it would be head, tail. They could flip a tail and a head, so the outcomes would be tail, heads. Or they could flip a tail and a tail, and the outcome would be tail, tail. So you can see that there are 4 outcomes here. So what is the theoretical probability of taking 2 left turns? Again, it is flipping head, head, making 2 left turns. That happens once out of 4 possibilities, right? So if we use our formula, probability is equal to photo, we would put 1 over 4. We would divide the top number by the bottom number. We would get 0.25 as our decimal number, and we could multiply it by 100 to get 25%. And lastly, question C, compare the experimental probability with the theoretical probability. All right, so we know that theoretical probability is 25% for taking 2 left turns, and the experimental probability is 22% for taking 2 left turns. So the theoretical probability for taking 2 left turns is greater than the experimental probability, which makes sense, right? So the key ideas that we have to remember with this assignment is that experimental probability is determined by completing experiments and tracking the outcomes. This is what actually happens, folks. Okay, this is when you do the experiment, these are your results. Theoretical probability is what we can expect to happen. And like I said at the beginning of this lesson, that's what we've been talking about in this unit up until this point, okay? Experimental and theoretical probability results may not be the same, but generally the more experiments you do, the closer the results will be to the theoretical probability. The assignment is on page 187, and you can do questions 4, 5, and 11. Thanks, guys.